Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. So, last session, we have made good progress and some things are working. So, all the pure virtual function names are being substituted. That's good. Now, we wanted to implement a whole generation of override and implicit flag for the entire primary vtable entries, yeah, which does not quite work yet. To do, walk both aisles until the end, then increment both of both aisles, fails search. Yes. Okay, how do we implement that? That's a big question. Yeah. Yeah. How do I do that? I think either we take out this stuff into a new function or this thing to a new function. Can we have a second loop here? Maybe. I would like to implement it simply, not make it more complicated. True. True. I mean, we could move this into a new function, which then returns true here and false otherwise. And then we increment outside. Yeah. But then we need to pass this thing and this. Anything else? No. Yeah. Yeah. Okay, let's see. So we create a new function and we say process primary vtable entry. Process primary vtable entry. Okay. We give it a class type and we give it these two here, entry and base entry. Okay, for starters, you can just make it here a local function. Yeah, and then we copy this stuff here. It will return bool. Yeah. And then here we return true, else return false, right? And oh, we also need to pass, no, it needs to be a member function. Yeah. There we go. How about we make it here? Put it below. And so we have our vtable. Vtable. Of course, we have to remove this. I'm stupid. Okay, there we go. Class type, entry, base entry. That's it. And then let's comment this out. And then we say, so if not, process primary vtable entry, class type, entry, base entry. Then we need to uncomment this here, put it here. So if that is not passing, then we need fallback. Or we say, hold on, let's do, if this is passing, then we say plus this, yeah, and continue, yeah, continue. Otherwise, we will take un, hold on, vtable count, vtable index. Otherwise, we take a copy of these two, un16t, vtable index copy equals this one, yeah, and then we do a base vtable index copy as well, and then we do if process primary vtable I think we need to put this in the scope. And this as well. And then here we put this guy as well, but we use, no, we use the same. And then, so here we just increment one aisle. If I think we need to have child loop here, while vtable index is smaller than vtable count. While vtable is smaller vtable count. And then we do this. And if it is succeeding, if it is succeeding, then we do the same here. We need to exit this loop somehow. And then here, if this would fail, then we would assign this to the copy, and this to the copy, and then we would do the same loop the other way around, where we take again this here. I do wonder, actually, do we really need 3 loops? Can't we just do 2 loops? That seems a bit too overcomplicated. What if we put the loops here? We have a copy. No. I think it has to be this way. Because we walk here, and if we reach a point where it's stuck, then it needs to go walk both sides. Yeah. Yeah. Entry, base entry. But then here we need to escape somehow. Here we need to escape. Else. And here we would do this. Yeah. It's quite a bit complicated. Yeah. Let's make this const. Here we can also do and so if both would fail, then vtable next. Actually, I think we don't need this here then anymore. We walk both aisles here. Copy, copy. Yeah. Okay, and so if both have failed, then both have failed here at the end here, then we set this again. And +1. And then we continue next iteration with these two. Yeah. I think that's could be right. Let's look through it. So we started these two. This one is up here. Yeah. This one always starts at 0. Yeah. Base vtable index. I think and we can make it the for loop here and move this in here. Okay. Okay. And then, so while this is smaller than this, why vtable index is smaller than this. If it's true. Okay, but we still need to also, when this is passing, then we need to go here to the next iteration. How do we do that? Breaking out doesn't work because then we would enter this loop here. And here the same. Can we use a go-to maybe? Oh. Maybe. We could use a go-to. I never use go-to, but here it would be applicable. Or we put this here into another function. But then we need to pass. Vtable index is smaller than count. Then we need to pass so many arguments. We need to pass vtable. By the way, this here is wrong. It should be this way, because we count this up. Yeah, we need to escape somehow here. So if we do a break, then we would also need a flag here to continue, but then I could just have a go-to. Or we could have, yeah, but then we would need to put it in a function. But then we need to pass this thing. Vtable count. Base vtable count. So we would need to pass this one, these indices, and the class type. 5 arguments. Yeah. So it would be entries, class type. So we would pass, let's see, this vtable, base vtable, and vtable index uint16t, vtable index, and uint16t base vtable index, right? And then we would need a copy of this. So we would need primary tables 1, 2, yeah. 1, 2. And then here we would copy this in here and this in there. And base vtable count, we would have these two, this and this, and these need to be passed as reference. Entry. And I think the class type can actually be passed as const. No. This one here. Const. 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 Okay. Okay. What are we missing? Reference. Okay. Very good. Very good. And then here we say process primary vtable entries 1. Class type vtable Actually, vtable we can also get from class type. Oh, it doesn't matter. Base vtable index, base vtable index. Then we create a copy and number 2. So number 2 goes down here. Then we comment out this and this. Okay. And then we say if this is successful, then we continue. If this is successful, then we also continue. We need a return then. Bool. So here return true, and here return false. Return true, return false. Mm-hmm. Mm-hmm. This loop walks both aisles, walks both vtables to the end, walks both vtables one after the other to the end until it finds. This loop walks both vtables one after the other until it finds a match or ends. Let's say the two child loops walk both vtables one after the other until it finds a match, until it finds a vtable entry match or the vtable ends. Okay, let's remove this here and this. Okay, so now what is happening? We have this big loop here, and then we have these sub loops inside where it will try to walk both sides if it does not find it on the first hit. So ideally it finds it right on the first hit, right? But it might not be always the case. I wonder if we make a copy here, then this means that here we check it twice, right? Or am I mistaken? I think we should base vtable index. Could it be that we have to do +1 here? So we start here at the, base indices, and then So we have done, because if we do this again, then we would check the same entry twice, right? So we should skip ahead this one. I think so. Yeah. Yeah, I think that makes sense. Okay, let's remove this here. Yeah. Oh boy. Well, couldn't be any more complicated. Oh boy. Let's see. Let's skip ahead to some other class. Let's do one of these here. Yeah. So, what do we have? Behavior module. Okay, so 48, vtable count 84, 48. Okay, that's a lot. Good, so what do we have here? Vtable index 0, 0. Vtable index copy is 0 and 0. Good. So we step in the first and it finds the first match right away. Perfect. True. Continue. Perfect. That's a best case scenario. We just find the thing right away. Everything is beautiful. No searching needed. Yeah. Okay. Let's see. Let's see if we ever hit here. Aha. There we go. So we are 59 and 6. 59 and 6. 59, 7. Okay, let's see. Vtable count. Yeah. Get damage state. Get subdual damage. It's not found. What is it? Get damage state. Get damage state. Get, it's here. So it will find it. It will find it at number 11. There we go. Okay, it found it. Get damage state, true, and continue. Perfect. Okay, that looks very good. Okay, this looks very good. Let's see if it ever hits here. Let's see. Yeah, okay, we have a hit here. Let's see if that is a legit hit. Yeah. Let's see. What do we have? Base vtable. Let's go to watch. vtable and base vtable. Entries 14 and 7. Let's make this larger. Okay, what is it not finding? 8, 8, 7, 8, 8, 6, 8, 6, 8, 6, 8. 8 is here. Refresh terrain. Yeah. Yeah. Yeah, it's not found in here. Mm-hmm. Mm-hmm. Refresh terrain. Base vtable. So that means this radar refresh terrain must be a new function, right? So we have the draw here, but that's weird. Init, reset, update, draw. Do we have this function in Thyme already? Radar, radar. We do. Okay, that's good. Let's see. Okay, so radar. Init, reset, update. Refresh terrain. Refresh terrain is here. Q terrain refresh. Q terrain refresh. Refresh terrain. So this is not an override. This is a pure virtual. Set shroud. So these look like 6 new functions. Refresh terrain. Q terrain refresh. New map. But then it's weird that draw is also pure virtual. Okay. Clear shroud. And set shroud level. But we also have a draw here. Draw. Ah, but it's a different draw. It has 4 ins here, I see. Okay, it's different than this draw. Okay, so these 6 functions here are new. And they are also new here. Yeah. And these should be positioned above it, actually. But I think it doesn't make a difference for a compiler. It would put it into this order likely at the end. Yeah. Okay, I think this is correct. Yeah. So that means now, so what have we hit? We have hit 8, 8, 8. So it has not found this one, the refresh terrain. Yeah. So the next one should be the 9, right? No? Okay, that's unexpected. Let's go back again. So here we are at radar. Okay, let's look at it once more. Radar. Good. So we are here right now. Good. So now we increment this and this. And 7 is smaller. It's not 7, draw. Ah, okay, so it looked for draw, but it didn't find draw. So we're done here. I see. So it only has init, reset, update, and that's it. It doesn't have draw. Okay, then this is correct, yeah. Yeah. Okay, let's see the next sample. What do we have here? 49. 49, that looks familiar. 49. 49. 49. 12. 49 and 12. 12. 12. Upgrade MUX CLC. Okay, yeah, it's not here. Upgrade MUX. Upgrade MUX, not process. Yeah. So the last one that matched was process upgrade removal and this one. Yeah, so this one is... This one should be marked now as override. Yeah. And this one is implicit, right? Yeah. Okay. I think this works correctly. Yeah. What do we have here? 50. 50 is this one here. 13, yeah. And 51 is this one here, yeah. And we have an error. Uh-oh. What do we have here? Vtable count is bigger than base vtable count, and that's not true. Particle system info, CLC xfer. Okay. Yeah. Is override true? Okay, that's interesting. I did not expect that. Vtable count. Okay, so for some reason, what is this class? Particle system template. For some reason, it has only the destructor. Let's see if it's already in Thyme. Particle system template. It's already in Thyme. Everything's in Thyme here, apparently. Yeah, it does have the destructor here. And particle system info has snapshots, which is implicit, is override. Is override, yeah. Yes, overrides. It's implicit. Okay, then I think this assert is not true. Okay, if we remove it, will we crash? That's a good question. We might, because of this. We might crash, yeah. Um, um, what was this assert again? Vtable count is bigger than base vtable count. Okay, my suspicion is that we will crash eventually then at this place here after this assert. Because the index can go over vtable count then, right? Maybe? Let's see. 1, 2, 3. 1, 2, 3. Yeah. There we go. Yeah. So, yeah. So we need to protect it against. Yeah, the question is, do we want to make a check here if vtable count is smaller than this, then continue? Maybe. Maybe. That way we can put this assert up here. And this assert. Oh, good question. Why is this hitting? That's what I don't understand. Let's see it once more. So, particle system info. It's at offset 0. I honestly have no idea why. I don't understand why this is smaller. That's weird. I would have expected that these three are now listed in here as implicit entries. Yeah. Strange. Okay, so here we are protected against this. For okay, I think the fix here is to say that vtable index. Yeah, I think the easiest fix is to simply add this to the condition here. If vtable count smaller than hold on. Vtable index is smaller than vtable count. Yeah. Or we take this out of this loop because a vtable, where is it is it is changing, but inside here, which is already checked here. No, here. Vtable index smaller, vtable count. Vtable is vtable. No, I think it makes sense because we count it up here. Yeah, so if vtable index, vtable count is not guaranteed to be smaller than this, then it makes sense to have this condition here as well. But in most cases, this will be smaller than this, but sometimes not. And so we need to test this here as well, because this could be the first condition to hit before this one is hit when we count it up here or here in one of these. Yeah. Yeah. I think this is correct, yeah. Okay. Good, let's see if that runs through. Let's remove. Okay, that ran through without errors. Okay. So if we look at our classes now, classes. So let's scroll a bit down here. Look at some update modules here. Base classes. Vtables. Vtables. And is implicit. Is override. Is implicit. Is override. I think this looks very good. I think this looks very good, yeah. I think it's all correct now. What we are still missing is a relationship from vtable entry to the base class, the bottommost base class that it overrides. How do we do that? Okay, but we already have quite some progress. It's really good. Yeah, it's quite complicated now, though. I don't like the complication of this. But okay, if that is necessary, then that's fine. Okay, let's delete this here. And okay, so we still need, yeah, to build those relationships. The question is how we do that. Oof. Yeah, that's a good question. This is tests. Yeah. How do we do that? Did we actually end up using this here now? Did we end up using this? No. Then we can also remove this again. Remove everything that we don't use. So we remove this one. Did we use this one? No. Remove. Remove everything. Did we use this? No. Remove. What about these guys? Still using? Maybe not. I think we can remove more count. Now it looks like we don't use this even, so let's remove that as well. Although, no, we don't need it, I think. All this code written, all unused. Okay, let's leave it at that for now. Yeah. Okay, so the problem is here we don't really walk into the outermost leaves, but we do it here. Here we walk, but not for the whole primary vtable. Yeah. Yeah. Let's override. Go. Okay. Ah, das ist hart. I mean, I mean, we have functions here to get the base class and the base class at offset 0. So if we have an index or a base offset, we can get the base class. Get base class depth. How do we do it? Base offset. Now we would have to go down all hierarchies get this info. Can move this here into a function. Process void process vtable entry update vtable entry override entry overrides so you put that here, class type entry, if not entry, entry overrides. Okay. Tree overrides. I think this can be static. Okay. Yeah, how do we build the relationships to the outermost, bottommost base class? I don't know. Yeah, base class index. Which we don't currently set. Yeah. Yeah, what do we do with it? I don't know what to say. I don't know what to say. This is this is this is hard. Oh. Okay, but we have come a long way already with the vtables. So this relationship would only I would only like to have to generate the comments that which functions, which base classes the virtuals belong to. Yeah. Yeah. But the question is, how do we do that most elegantly? Getting it to the direct base class, that would be easy. But I don't know how useful that is. I think it would be more useful. Yeah. How do we build that relationship? certainly would mean that base class. What we can do is we make a parse, a very expensive parse. We create a function where we give it an index, and then it returns us a base class. But it's a base class. So here, get base class at depth. I don't think we use this function. I can probably remove that. Also, don't use this function. Yeah, I would like to keep this function though. Maybe we need it for something later. This still could be useful for something. I don't know. This one I think we definitely use. Right. Yeah, we use this one. Yeah, I would like to keep these two. We are not using them right now, but maybe we need it for something. Yeah, I wouldn't like to delete it yet. What we can do is we make a function where we just pass an index, and it will give us one of the base classes here. Any way, and then we say we write a function where we simply go through all indices, and then we check if a function is in there as a declaration. Yeah, and then we assign that index to this class. Yeah. What is wrong here? Why is all this red? So process. Let's call this primary vtable overrides. Process vtable overrides and pure virtuals. What is happening here? Somehow the rename doesn't work. How about we put this also in a function? Vtable. So we have this one, and then we do process vtable entry pure virtual, and we give a class type entry vtable, and we give a parent entry. Then we take this. And then this is parent entry. Entry. Oh, God. Parent entry. To avoid confusion, let's do tree override. Base class type, base entry. Base class type, base entry. There we go. Okay. Yeah, so I think what we can do is, so what's the time? 1 hour 35. So we create a function. Yeah. So index t get base class by index. Well, let's say get get base class by index. Get base class in whole hierarchy by index. And then we do index t index. Then we say here base class index. Base class index. The most button base class that this virtual function overrides. Okay, let's implement this. So base class return base class null pointer and we say for index t I equals 0, I smaller than base classes. Let's do index t count dot size count const count plus plus I would say we do if index is smaller than count, then return base classes index. Okay. Why is this base class? There we go. Otherwise Otherwise, for index I, otherwise base class equals this, and then index minus I. Does that make sense? If base class is not null pointer, break. Or we say if I is smaller count and base class is null pointer. Return base class. Yeah, maybe. Let's go through it. So basically, the first indices would be for the topmost base classes. Then we go to the first. Oh, I see a mistake here. We need to do m base classes. Base classes I. And we also need we need a span for classes. Classes, base classes dot base offset. No, class index. There we go. And then class type. Class type dot. There we go. And then we pass classes here. Index minus I. Index minus I. Does that make sense? Yeah, I think so. Index. Index minus I. Index. Then it goes in there. I mean, we have a little bit of freedom of how we want the indexing to be done, right? There are different ways. We could also Could also directly go in here doing this loop. Or, well, it's not a loop. So index -1, is that correct? Index. Yeah, probably. Yeah. Yeah, it looks about right. Yeah. I think I prefer to have this check here. Then at least it's possible to set a breakpoint for it. Could also make a return here, and here. Yeah. Yeah, let's do returns. Return. Well, here we also use this method. No, let's keep it then. Here we use the same way. Can also remove this here. Good. I expect that this will work, and then we basically would create a new function, another. So we have the process vtable here. How about we move process vtables here on the top, and then we, oh my gosh, we take all this garbage here and we move it. We move it here, and then put the breakpoint back here, and then we create a new process. Let's call it void process primary vtable process primary vtable. What is it we want to do? Base class relationship. Primary vtable base class relationship. And then we give a class type. And then we implement that. So the function will probably start similar to how we do the others. Let's take this here as our starting ground. Starting ground here. Class, base classes. Yeah. So I think what we do is class type get base class. How about we call this function from whole, get base class from whole hierarchy by index. And we give classes and by the way, this is wrong. We only want the first vtable front. For index t base class index equals 0, we do true plus plus base class index. Base class index, base class. If base class is null pointer, then we break. Otherwise, we need to iterate. Get base class from whole hierarchy by index. Oh boy. I think we can remove this assert. Oh, this will be expensive. Yeah. Okay, how about we continue next session? It has been 2 hours now. Take a break. Yeah, but I think this should be a reasonable approach. Yeah. It will be quite a bit of processing here, but as long as it gives us correct results, I'm happy with it. Maybe there are better ways to do this, but you know, maybe I won't be able to figure out the most efficient way to do this. So if I just get one way to do it, I think, and it's correct, then I think that's good enough, right? I mean, it's not a performance critical application here, so don't have to have perfect implementation. Yeah. Yeah, basically there will be 2 for loops, one where we go through the whole vtable, and then the child loop will be likely this one, where we go fetch all the base classes, and then actually we need, yeah, and then in here we check, no, and then there will be another child loop, where we check, compare all the items inside. Oof. Oof. Ja. Ja. Okay, let's already call this function. It's basically here. Yeah, it needs to be in a new loop because the first process needs to be done first. Right, class type. So it's like these steps, they can't be put together. Yeah, okay. Yeah, then we continue here next session. Good. All right, then I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye. Let's stop the video exactly at 2 hours. So, 2, 1, go.